AP Calculus, AB 2017, number 3, calculator inactive. Let's get started. The function f is differentiable on the closed interval from -6 to 5, including -6 and +5, and it satisfies this condition, f of -2 equals 7. That'll come in handy pretty soon. The graph of f prime, the derivative of f, consists of a semicircle, as shown. They tell you that so you don't assume it's a parabola or anything other than that. 3 line segments, there's one, there's one, shown in the figure above. Keep in mind this is the derivative, not the original function. Here goes. Part A, find the values of f of -6 and f of 5. There are a lot of ways of looking at this, and I am going to go about it this way. F of -6, well, what we have is the derivative, so we're going to have to take an integral to get what we need, and we know it needs to land at -6. So we'll do that. And f prime of x dx. Well, where is it going to start? Well, why don't we start with something we know, and they told us that right there. So this is where I say there's more than one way of looking at this. I'm going to do it a way that is a little bit different than what you see in the scoring guidelines, and I'm going to use the fundamental theorem of calculus here. So if I took the antiderivative of this, I would have f of x, basically, from -2 to -6, and that means I would have f of -6 minus f of -2. Okay, well that's fantastic. What we're going to do is sort of mess with this a little bit and get a good equation that we can work with. So I'm actually going to go ahead and figure out what this is right here, because we can. This is really just accumulated area. Okay? Again, not the only way of looking at this, but this is the way my mind goes about it, and yours doesn't have to go that way. But I can figure this out geometrically. So this piece right here, -2 to -6, is this triangle, -2 to -6, and technically, because we're going backwards, what is above the x-axis is going to count negative. If you want to think about it differently, I'm going to bring my work down. If you want to think about it differently, you could say it's the integral from -6 to -2, but you'd put a negative in the front. You could do that, and that is equal to, I'm going to leave this step in the middle out, f of -6 minus f of -2. Now, again, they asked us to find f of -6, so we can just bring that over. So let's do that. So we're going to have negative integral from -6 to -2. I'm writing way too much here. A lot of this can happen in your head. You can skip a lot of steps. I'm going fast, though. There's this. And don't lose track of what they're asking. They want f of -6 and f of 5. It's still going to take a little more work. So we're going to find out what this is, and then we're going to change its sign. This right here is the area of the triangle, again, from x equals -6 to x equals -2. So it's 1/2 base, excuse me, base times height. Base is 4, height is 2. So 1/2, 4 times 2, don't forget that negative, plus f of -2, lucky us, they told us what it is, that would be 7. And that is equal to f of -6, which is what they're asking for. So this is going to give me, let's see, 4, -4 plus 7, so 3 is f of -6. Okay, so that's one way of looking at it. Another way of looking at it is we could find that area and just basically offset it with our starting point. Totally doable. I've done it that way before, like how much area would we accumulate from here to here? And technically it'd be a negative area, but then we actually started at 7, so 7 plus that negative area. It works that way as well. You don't have to do it that way. So let's do the other part of part A, where they want f of 5. Let's go ahead and set it up the same way we did the other one. So we're going to start at -2, and we're going to go to 5, +5. I may have said -5 a second ago. I meant +5. And this is going to be f of 5 minus f of -2. Okay, so we're going to find this area right here. I skipped that step this time. We're going to find this area right here, and we're going to plug in the 7 they gave us. So f of 5 minus 7, skipping some steps this time. The area from -2 to 5, let's go. -2 to 5 is going to be a semicircle and a triangle, and the semicircle is going to have a negative area. We are truly going from -2 to 5, so we're going forward, so below is negative, above is positive, and we have a half of a circle, so it would be 1/2 pi r squared. 1/2 pi times the radius is 2, so 1/2 pi, but it's going to be negative, times the radius squared. I'm having to bring it down. I didn't space this well. And then plus the area of this triangle. And this triangle is going to be 1/2 3 times 2 base times height. So 1/2 3 times 2. And I did not space this well at all. My apologies. So this 2 cancels with one of those, and we're going to have negative 2 pi here. We're going to have after that, so plus 3, and that's going to give me f of 5 minus 7. So f of 5 is, let's bring this 7 over, that's going to give me 10 and negative 2 pi. So we have just found f of negative 6 and f of 5. Let's move on. Part B, I'm going to use a separate piece of paper. On what intervals, actually I don't need to, I can do this. On what intervals is f increasing, and then justify your answer. So I am looking at the derivative, which should be pretty straightforward. A function is increasing when its derivative is positive. So I'm looking for where the derivative is positive. This one's going to be pretty easy. So derivative is positive, then negative, then positive. So the function is going to be increasing, decreasing, increasing on those intervals. So let's just articulate it that way. So f of x is positive on, it looks like an, it's on the intervals from negative 6 to 2 and from 2 to 5. And as I write this, I'm trying to be a little careful about the endpoints of the intervals, about technically where the function, where the derivative is positive or where it's actually 0. And then they get a little bit meticulous, well, they get a little bit, I don't know, loose, I should say. Not meticulous, it's the opposite of meticulous. They get a little bit loose with the way they word their answer. They put brackets on these. So you could make the argument that the function is increasing on the intervals from negative 6 to 2 parenthesis, and then 2 parenthesis to 5 parenthesis to match what you have here. You're looking at the scoring guidelines right now, by the way, but I think you knew that. And so you could put parentheses here and here and here, and you would still get it right. So I have never known of a circumstance where people who grade the free response questions to be so picky about it that they're like, oh, it should have been a bracket instead of a parenthesis, particularly in this context. I'm going to be consistent with what they did, though. So this is true. The function, the derivative is positive on these intervals. So therefore, you don't have to use the word therefore, but there's a reason it's therefore. Ha ha, bad, that was a bad joke and bad grammar. Therefore, f is increasing on the interval from negative 6 to 2. And again, bracket, parenthesis, not going to be a huge deal. And 2 to 5. Okay. All right, let's move on to part C, where I will use a separate piece of paper. And it says find the absolute minimum value of f on the closed interval from negative 6 to 5, and then justify your answer. Okay, let me read that again and point out what I'm looking at. Minimum value, that is an extreme value situation. So I'm going to be dealing with the extreme value theorem. The extreme value theorem means that I need to look where, well, where? Let's find out. I need to consider where the derivative equals 0. Also, you like those sound effects. I also need to consider where the derivative doesn't exist. That's not a circumstance here. I also need to consider the end points of the interval. So let's get started by making a table, and we're going to justify this as we go. So I'm going to start the work and then begin the actual justification. So here goes. I'm going to make a table of all the potential things that I could have as maximum or minimum values. Actually, minimum is what I'm going for. So endpoint of an interval, x value where the derivative equals 0. There's one. X value where the derivative equals 0. There's another. X value where the derivative equals 0, and that's also the endpoint of an interval. So we're going to consider that. So we're going to find all of these that we can. Well, lucky us, we already have some answers from part A, right? So we don't have to do a whole bunch here. We know that this one is 3. We know that this one is 10 minus 2 pi. We didn't write it that way. We wrote negative 2 pi plus 10, but that works. And then we also have f of negative 2, which they told us was 7. So the only one we really have to find is this one. And I'm wondering if we really even have to find it at all. And so let's check to see if we do. So I'm going to justify this in words in a minute, but check this out. I'm looking for a minimum. And a minimum is going to occur where I have an endpoint or the derivative equals 0. But let's get a little more specific. I'm looking at the derivative here. And if I'm looking at the derivative but talking about my original function, then I would say, okay, well, derivative is positive then negative, so my function is increasing then decreasing. This is actually a maximum. So the answer is not that, which we kind of can tell already because 3 is less than 7, so we know it's not the minimum, not the absolute minimum. But here we are transitioning from a negative to a positive derivative, therefore the function is going to be decreasing then increasing, and the transition happens at the critical point of x equals 2. So sure enough, 2 is a point we should consider. Negative 2, really we didn't need it. It was superfluous. I love that word, but I didn't need it. If you have time in your explanation, use the word superfluous. You don't need negative 2, it's superfluous. Okay, we're going to figure out what happens at 2, and by saying what happens at 2, I really want to clarify what I mean. Let's find the value of the function at 2. So f of 2 is going to equal, well, the value of the function at negative 2 plus the accumulated area from negative 2 to 2. So remember in part A, when we were going about it this really long, elaborate way where we use the fundamental theorem of calculus, and it works and it's fine. I'm doing it a little bit differently this time. I'm going to say, here's our starting point, which this is 7, because they told you. This is 7, and then I'm going to add some accumulated area. So this is what I'm doing. I could have done part A this way, and it ends up the same. Just felt like explaining it more than one way. So we're going to have 7 plus, okay, accumulated area from negative 2 to 2, and that is the semicircle that is below the x-axis. So negative 1/2 pi over 2, negative 1/2 pi times pi squared. So negative pi over 2 times 2 squared. If I said pi squared, I'm sorry. There we go. All right, so we're going to work on that, and then we cancel those out. We're going to have 7 minus 2 pi. Okay, we're looking for the absolute minimum, and I do need to justify this, and I will in just a moment. So again, actually, let's go ahead and justify it now. In this justification, I need to talk about why I chose the points that I chose. So the minimum, and I'm going to be real specific with my language, the absolute minimum will occur where the derivative is equal to 0 or at the endpoint of the endpoints of the interval. Okay? Closed interval. All right. So we consider all of these. Again, this one's not really one that we should consider. It didn't waste our time because they told us that one. And so we are going to find the smallest number. Again, that one's out. And we were probably like, oh, but this is calculator inactive. How am I going to find it? How am I going to find it? Let's think about this. Think about this logically. Pi is 3. Let's just say pi is 3, right? 7 minus 2 times 3. This is 4. Okay? And then I'm going to have, let's see, 3 here. This is 7 minus 2 times 3. This is 10 minus 2 times 3. So this is going to be, oh, no, I'm sorry. I said that wrong. 2 times 3 is 6. Ah, wow. Way off in my head. I was doing 7 minus 3. Okay, 7 minus 2 times 3 is going to give me 1. This is basically like 1-ish. Okay, if you want to get all technical, you could do that. It's not 1, but it's pretty close to 1. So if we're estimating, that would be it. So 10 minus 6, that would be 4. So if I'm looking for the lowest, we found it. So this is the minimum, and so we're going to write that down. The absolute minimum is, okay, here's a mistake a lot of people make. They'll say, it's 2. No, it's at 2. It is at x equals 2. I'm going to get really specific with it, and I'm going to say that it is this. There we go. That was the end of that sentence. We'll put a period. Part D. For each of this and this, find the value or explain what does not exist. Okay, we'll do that. So f double prime of -5, and we're going to find the value of that if we can. Let's find out what the slope of the slope is at -5. This should be pretty easy. Here goes. This is the slope. Let's find the slope of the slope. The slope of the slope at -5 would be the slope of this line. So we're just going to find the slope from here to here, and it's rise over run. So we rose, terrible southern accent, rose. We rose -2, so we fell 2, and then we went over 4. So this is -2 over 4, so -1/2, reduce it or not. Okay, f double prime of 3. Let's look at the graph. Let's find the slope at 3. Oh, the slope of the slope does not exist at 3, and I want to explain why. Now, here's what not to do. Do not explain why by saying, because it's where 2 lines meet. What? Okay, yeah, I mean, that is true, but that's not mathematically correct. The slope from the left doesn't match the slope from the right, and we're going to get really technical with this. This does not exist because, and we're pulling out an old formula here. This does not exist because the slope from the left doesn't match the slope from the right, and we're going to use the formula for slope at a point. So if you're looking at the time on this and you're saying, hey, you've gone over 15 minutes, I know, it's because I'm explaining little things like this. The slope at a point is the limit as x approaches c of f of x minus f of c over x minus c. Okay? Well, if I want the slope at a point, but it's where 2 lines meet, or 2 different functions meet in this case, then we're going to have to find the slope from this side and the slope from this side. So to finish our sentence, this doesn't exist because the slope as we approach 3 from the left does not equal the slope as we approach 3 from the right. And that's why it doesn't exist. This one didn't require an explanation. This one did. Okay, let's see if we got all 9 points. I'm pulling out the scoring guideline, pulling out my answers. All right, here goes number 3, part A. Did I use the initial condition? The initial condition meaning f of -2. Now, they may have done theirs a little bit differently. They actually did do theirs differently than I did. But they used the 7, and I got a point for using the 7. I used it on both circumstances, okay? Different, might look different than theirs. And then I found f of -6, which they got to be 3. F of 5, which they found to be 10 minus 2 pi. I wrote it differently, but it's the same thing. Okay, part B. Answer with the justification. And actually, when I did this one, I was following the format of the answer key very closely because I wanted to talk about the brackets and parentheses. So what I have here is basically what I have here. Left a few words out, but it's all there. So answer with the justification, both there. All right, let's move on to part C. Consider x equals 2. Hey, we considered x equals 2. We got it to be about 1. They never said it about equaled 1. I did. They didn't. That's okay. And answer with the justification. That justification needs to involve this, where I'm pointing, and this as well. And also, this table is going to come in very handy. And we did that a lot in class. Okay. So we just earned both points there, and then last part we get f of -5, which is -1/2, and then we got this one. Well, did we get this one? I don't know. Let's see. Now it gets tricky. Maybe I didn't earn a point. Here goes. F double prime of 3 does not exist with explanation. Their explanation included the slopes from both different sides. So now in my mind, I'm wondering, would I get credit for that or not? So we had this part. We did not have this part where they talked about the slope on this side is 2, the slope on this side is -1. So to be consistent with what they put, I'm going to go back and change it. And just kind of extra work down here at the bottom, and I would say the limit as x approaches 3. Did we get credit for that one? I'm gonna optimistically say yes. That slope was 2. But I can't say for sure because I wasn't in the room when they graded it. So if you have time, the more you write, the better. Now we have truly shown that these are two separate things and therefore they do not equal.